So if you haven't done so already, make sure you pick up your homework journal. What I did was I just kind of looked through it. Did you do promise from each section? If you did, you got full credit. I kind of just based it off of how much it looked like you needed. I don't think I gave lower than a 50, and you had to do like nothing to get 50. So as long as you're low and you got like a 70, 80, 90, 100. But all the grades are on Blackboard. All right. Solving non-homogeneous systems. Two methods. Right, just like when we did linear equations, you first have to find your complementary function, which is what we did with the non-homogeneous. Then you need to find the particular solution for the f of t. And there are two methods, undetermined coefficient and variation of parameters. Undetermined coefficients, once again, has two requirements. Your coefficient matrix A has to be constant. Right, that means all your coefficients are constant, just like with the linear equations. And your f has to be constant polynomial, exponential functions, sines, cosines, or finite sums products of these forms, just like with linear systems. Right, and then from there, undetermined coefficients is exactly the same, except you have components of the vectors. And so the first component has to match the first component of f, the second component matches the second component of f, so on and so forth. And then you solve for your coefficients from there. That is a bit more of a pain in the ass. I'll be using variation parameters exclusively, because it's just a lot easier, especially when you have a calculator. So here's the idea of variation of parameters. You want to form your fundamental matrix which is psi of t. Right, it's just psi of t is formed. Each column is one of your independent solutions. Right, so column 1 would be x1, column 2 would be x2, column 3, x3, so on and so forth. That is your fundamental matrix of the system. There are two properties that we make use of. It's non-singular. And since it's a fundamental matrix, psi prime is equal to A times psi. Your particular solution is then of the form psi of t times u of t. Right, go through the derivation. It all leads to this. With variation parameters, that is your particular solution. It's psi times the antiderivative of the inverse of psi times f dt. Doing it by hand makes this method really annoying. Because the first thing you have to do is form your fundamental matrix, which that in of itself is not an issue. Then you need to find its inverse. That sucks. Oh, then you have to do matrix product of the inverse of f. Then you have to take that antiderivative. Then you get to do that matrix product with the original psi. Yeah, doing it by hand, that's not fun. But we have calculators. So don't try and do it by hand. So let's solve this system. Write it in matrix form first. That would be in matrix form, right? First, find the complementary x sub c. This is just, you act like this bit here is not there. Right? It's the homogeneous part. It needs to be named eigenvalues. It's lambda squared minus lambda. Oh. Minus 6 plus 6 is 0. That's nice. Zero and 1 are the two eigenvalues. That is the best outcome. You get two eigenvalues from a 2 by 2. That means we're going to get two linearly independent solutions right off the bat. Right? All right. So for lambda equals 0, remember, plug it back in to your matrix for reduce it. That's going to give us, because it's 0, and that is extremely easy to see. That's going to reduce to that. X1, e to the 0t, which is just 1, times 1, 1. There's the first solution. Second solution, plug lambda equals 1 back in. Going to give us what? 2, -3, 2, -3. Again, that shouldn't be difficult to see. Sorry. 1, -3, half, 0, 0. should get the solution 3, 2, e to the t. Right? Or any multiple of that. There's a complementary solution. Now for the particular. Coefficients would be really easy for this one. Let's do undetermined coefficients for this one. This one's actually pretty easy. F of t was 4, negative 1. So you would guess the form would be a constant and a constant. However, look at the first solution in the complementary. That's a constant, right? That means that particular repeats. Multiply by t. Does a constant times t appear in your complementary? No. So we're going to take that to be our particular form. This would mean that x prime is AB, right? Now plug that back into the original system. So it says x prime equals 3, negative 3, 2, negative 2. Times xp plus f of t. All right, do that matrix operations. So product and add. Three AT minus 3BT plus 4. 2AT minus 2BT minus 1. Reduce that down. Or not reduce it down, but interpret that as your system of equations. big set. So I'll just go with what I was going to do originally, just use duration parameters. Form your fundamental matrix. First column is x1. Second column is x2. I'm just going to call it x for this purpose. I'm going to have it print out everything for me. This is the command to find the inverse of a matrix, and then just write it in matrix form. Oh, I also need to define my f, don't I? F was, what did you say it was? 4 -1. So product, remember we want to anti-differentiate the inverse times f, right? Dot f. And again, I want that in matrix form. The period represents matrix product. You could also just use the dot command. I find the period to be easier. That'll give us the antiderivative. And then the particular solution is x of t dotted with this. Let's put that in matrix form. There's your particular solution. Right. I just have everything listed out so we can see what it all is. So I'm just going to go ahead and write these on the slides. And then obviously the general solution is now the complementary that we just found, plus that particular thing, you're done. Really easy with a calculator to do variation parameters. I recommend trying to figure it out on your TI Inspire before next class. Maybe I'll show it off next class. And I'll get these onto the slides. We'll pick up here on Tuesday. Have a good weekend. Because I also told them on that as well.
Yeah, so it seems like whatever you told them to resolve the issue,